Okay, hello everybody. Okay, it's Thursday morning, so you should be watching this Thursday afternoon, so good afternoon. We're trying this new way of doing this, so I will be online, but I'm showing you this as a video so we don't have the same technical difficulties as last time. So I'm going to go over the graphing sheet that we were supposed to do last time, but we were having so much technical difficulties with. Okay, so I am going to have this is already posted, but I am going to be using some sheets that I will be posting later. Okay, so let's do this together. So this is our first graphing sheet. It's graphing sheet number 1. Now, what I'd like you to do is take your ruler and make a dotted line. I'm using color, you can use pencil, to separate the different segments of the trip. Okay, now I'm going to do that for all of them right now. Okay, I'm not going to do them all at once, but I'm going to do the lines all at once just for convenience. Okay. Now, so you were supposed to have this done, but because there was difficulties, I'm just going to redo it so you can watch the video. If you're okay with this, you can jump forward to the next part of the video. Okay, so for the first part of the trip, there is a diagonal line. That diagonal line means that there's constant velocity. This is also a diagonal line, so it's also a constant velocity, but there are two different velocities. So we're going to say, I'm going to call this 1. I'm going to call this 2. You can call it A, B, okay? Number 1, object is moving north. And I know this because there's a north sign right there, okay? North at a constant velocity. And that's it. The second part of the trip, the object continues north at a slower constant velocity. So these two parts of the trip are independent of each other. They're different. They're both constant velocity. They're both north, but they're different speeds. Okay. All right, let's do the same thing for all of these. Now, let's call this 2 here, and we're going to call this 1. Okay. Now, I'm going to come back to this because we do need to talk about how long they're traveling as well. So I'll put that in afterwards. So in the first part of the trip, object is stationary 6 meters north of the observer. You could also say the origin, okay? And I'm going to put the time in now. For 6 seconds. In the second part of the trip, object travels south at a constant velocity. Now you could also say that it's traveling back to the origin, all right? But we can leave that. Don't need that. Now I'm going to go jumping back here. So this first part of the trip, the object is moving north for 3 seconds. Okay, because it goes from 0 to 3. And then from this one here, from 3 to 8, that's 5 seconds. So I'm going to put 5 seconds here. And I need to put the time here as well. The object travels for 3 seconds. Sorry, not 3. For 4 seconds. Because it's going from 6 to 10. for 4 seconds south at a constant velocity. Okay, this one here, number 1. Again, its object is starting from some faraway point, but it's not moving north. And it's not stationary. It's traveling south. So, object, stationary, and for how long? From 0 to 5 seconds. For 5 seconds. Eight meters north of, now you can say observer again, but just to show you there's another possibility, I'm going to say 8 meters north of the origin. Okay. And the second part of the trip, oh my goodness, okay, I made a mistake here. Object starts, cross that out, 8 meters north of the origin and moves south for 5 seconds. And number 2, object moves north at constant velocity at so we're going from 5 to 9, so that's 4 seconds. Okay. Now, underneath here, I'm going to do this in green. To get the average velocity, you have to use the 2 endpoints, and you get a mark, and actually I'm going to use a different color. I'm going to use red. You have to draw a line joining the endpoints to get a mark. Okay, so this one would be like this. That one would be like that. And this one would be like this. Okay, so take a look. Okay, so the first one you can use rise over run. The second one you could, but it would be rough. And the third one you can definitely not use rise over run. Okay, and because you can't, unless you can count the boxes, you shouldn't use rise over run. So average velocity is the slope of the endpoint. So m is equal to, I'm going to use rise over run for this one. Rise over run, pull this up a little bit for you, equals 10 meters north over 8 seconds. And then we did that, and that's meters per second north. So I want you to punch that in. We already did that in class, but I want you to punch it again. So 10 divided by 8. Get that. Now over here, m is going to be equal to y2 minus y1 over x2 minus x1. Now remember, this is the second point. So this is going to have to be 0 minus 6 meters north. And yes, you have to put the direction in, over 10 minus 0 seconds. So it's going to be negative 6 over 10, which is basically negative 0.6 meters per second north. And finally, this one is the same thing. You're going to have to use y2 minus y1 over x2 minus x1. So that's going to be 9. I'm sorry, not 9. It's going to be 7 minus 8 over 9 minus 0. So it's going to be negative 1 over 9. And I believe, if I'm not mistaken, it's 0.1 repeated, but I want you to punch that in. So it's a negative number, and it's going to be 0 point something meters per second north. Now notice it says negative and it says north. You can also write it down as positive and south. Okay, but you can just leave the answer as that. Okay, so punch that in. It should be negative 0.1 repeated. Okay. Now down here, the instantaneous velocity, you have to be asked a specific point. In this sheet I said 4 seconds. 4 seconds is just an arbitrary number that I picked. I could have asked you for 6 seconds, 8 seconds, 9 seconds, anything. But you look at this particular graph and you go over to 4 seconds and you go up, okay? And oh, this is in the second segment, okay? So the instantaneous velocity has to be calculated for the second segment, okay? So because it's in the second segment, I'm going to do this in red. Okay, so V instantaneous, we're going to write like that, okay, because this here over here, this is V average. Now we're going to do V instantaneous is going to be the slope of segment 2. Okay, just to show you, you do not have to write that all the time. You can go straight from V instantaneous, okay, but I'm just showing you that it's for segment 2. So this is going to be y2 minus y1 over x2 minus x1, and that's going to be 10 minus 6 meters north over 8 minus 0 seconds. So that's 4 over 8, which is 0.5 meters per second north. Okay, so you've just figured out the instantaneous velocity for that particular graph at that particular point. Now, in the second graph, you'll see if you go to 4 seconds and go up, oh, this is at the first segment. So V instantaneous is equal to the slope of 1. Now, you should not have to calculate this at all because you are smart people and you're going to say, oh, hey, that's a horizontal line. That means there is no slope. Slope is 0. Okay? And you say it's 0, and don't just say it's 0, you got to give an explanation. That I know that you know what's going on. So you just write in brackets, it's a horizontal line. Any horizontal line means 0 slope. Okay, and finally, the third graph, if you go over to 4 seconds, I forgot to number this one. If you go to 4 seconds, it's in the first segment. It's in segment 1. So V instantaneous is equal to slope of the first section. And that's not 0 this time. It's y2 minus y1 over x2 minus x1. So that's going to be, okay, wait, let me see. It's going to be 5 minus 8 meters north over 5 minus 0 seconds. So that's going to be negative 3 over 5 meters per second. So that's going to be equal to negative 0.6 meters per second north. Okay, so that's the V instantaneous. Okay, now I want you to stop the video, okay, and I want you to try the exact same thing on practice sheet 1B or 1A. I don't know which one it's called. I think it's, so it's the second one. It looks almost identical to these graphs, but I've changed them slightly. So I want you to do the stop and do the top portion of this. Okay, and I'm going to come back to the bottom after that. Okay, so freeze it and stop.